I think most of you know me, but for those of you who don't, I'm Dr. Lisa Hicks, the chair of the Sustainable Product Design and Innovation program here at Keene State College. We call it SPDI for short. So I welcome you all to our student presentation of the Manufacturing Enterprise projects. We have 2 teams this year for this course. For these projects, they went through the new product design process, developing the manufacturing processes, created a pilot run of 10 units, and sold them. They did a really great job, and I think you'll find these presentations really compelling. I know that we have invited our SME Society of Manufacturing Engineers professional chapter to join us. And so glad you're all here. And so first, what I'm going to quickly do is introduce our great SPDI team here. The instructor for the course is Dr. Hassan Habib.
Hi, my name is MD Hassan Habib, and yeah, I was very lucky to instruct them for this course. So they basically used a lot of like industrial and manufacturing tools, and I think I can say some of them, like they used the critical path method, the Fishbone diagram, and they also used a lot of process sheet, work instruction, and Gantt chart, like to model, to process, to like keep track of everything. And if I just want to talk about the research, personally, I'm doing like the research on biofabrication. I really like it. So yeah, I'm looking forward to this webinar. Thank you.
Great, thank you. Okay, and then our great lab instructors who've provided great lab and student support for these projects. So we'll start with Warren Hurd.
Hello, I'm Warren Hurd. I'm the metal lab supervisor. We deal with metals and also additive manufacturing, 3D printing, and some laser cutting. Have lots of experience in industry, and probably bring like 40 plus years of industry experience with me. So I'm here to help the students in any way I can, and to help teach and fill in things, keep things running, and keep things happy.
Yes, all right, awesome. Okay, and then Curtis Mead, our other great lab instructor.
Yeah, hello, I'm Curtis Mead, and I'm the Wood Lab supervisor. And I always look forward in the fall to Manufacturing Enterprise because it's a very dynamic class, and they have brought a lot of skills with them, and they are ready to take right off. So it's very exciting.
Great, thank you. And then I'd also like to introduce our new SPDI faculty member, Dr. Jared Nelson. If you just want to say hi and.
Hi, everyone. I'm excited to be here in Keene and part of this program. It was just a year ago that I was part of the audience for this presentation, and this was one of the things that wowed my socks off and really made this an exciting opportunity for me to join the faculty at Keene. So excited to be a part of the program, and excited for the presentations this evening.
Great. So many thanks, many thanks. Okay, so the way the presentation will be, we'll start out with the Pendant Light team, and then we'll have a 5-minute Q&A after that, and those students will be, you'll be able to talk with them, and you can put your questions in the Q&A. Then we will do the Headphone Stand Charger. And again, we'll have a 5-minute Q&A after that. I do have a quick question here about, will there also be a portfolio night? And yes, that will be at the end of May. We have the semester started late, so we will be going towards the end of May, right before the Memorial Day weekend. So yes, and so we'll be having more fun presentations then. So, okay, so let's see. I think we are good to go here.
So thank you everyone for joining us at this Zoom meeting. My name is Liam. I'm the production manager of the Pendant Light group for the Manufacturing Enterprise capstone course. Just a quick background on the capstone course. This course was originally designed to sort of give us a little taste of what it's like to be in a new product development team and sort of all the problems and solutions that may come with it. And I'm going to let the team introduce themselves, starting with Zach.
Hi, I'm Zach Stevenson. I was a quality control manager as well as working on the production team for this project.
Hello, I'm Seamus Wibben, and I was the accountant and design engineer.
Hello, I'm Haley Alberty, and I was the manufacturing engineer.
My name is Isaac Keene, and I was one of the production engineers for this project.
And my name is Aiden Bowen, and I worked in quality control and the production team as well.
And Will, at the very end, he did a lot of our electrical work along with Isaac. He won't be joining us today, so instead Isaac is going to present some of his slides for him. Just a real quick agenda, what the PowerPoint is going to cover. An introduction, obviously, we're a little over halfway through the introduction. Then we're going to cycle into some design, production and process, and at the tail end, we're going to have a few slides on accounting. So the actual pendant itself, the idea was to have wood sort of illuminated. To do that, we used wood veneer, which is basically just paper thin wood. And we wanted it to provide some sort of ambient lighting and maybe even give a little bit of task lighting down below. You can see my mouse right here. The light will shoot up through there and then obviously illuminate this entire wooden frame. Then we have a quick video I'm going to show you guys. So we've got a couple of jigs that we used. That was built by Zach and Aiden. This is that same jig in action. We're sanding off some excess veneer. And we did some 3D printing. This is printing the canopy that actually mounts to the ceiling. And then here's the final product, hung up. And now I'm going to pass it off to Seamus.
Here we see the finished pendant installed and on display. These pictures were taken after I installed the pendant into my house. To do so, I utilized the light socket adapter that was provided in the kit. I found it to be a very calm, warm, and welcoming display that provided adequate light without being a distraction to the eye.
So we used a bunch of organizational tools to help us achieve this. One of the biggest ones we used were Gantt charts. This is sort of a massive Gantt chart that we used. And it just sort of gave us an idea sort of how large of a window we had to complete X amount of tasks, what sort of tasks had to be completed before other tasks could be started, and everything along those lines. This is a micro Gantt chart. This was a lot easier for us to sort of digest than looking at this massive Gantt chart. And it's 1 week. It says this is how many days it's going to take for this task, and this is how many it's going to take for this task. And some design research and development.
Here we see a list of materials that provides a good overview of the basic components. On the left, we see the materials or components. In the center, we see the part numbers that we've assigned to those components. And on the right, we see the purpose that those materials were used for.
So this right here is actually our first prototype that I had rendered. And the idea was to wrap the veneer around sort of these 3 wooden arms. And then we ended up ditching that idea because we found out that wrapping paper thin wood around 3 arms isn't the easiest thing to do. It kept cracking and breaking on us. So instead we decided to cut the veneer in half, 2 separate pieces, much less of an arc. And then we would have the ability to mount even more lights on the inside of this sort of internal frame. And here's a picture of it illuminated.
Yeah, so even once we changed the design to reflect more of like a realistic capability of the veneer, we still ran into the problem of its natural fragility. So to remedy this, we decided that the best thing to do would be to reinforce the veneer with a material that would allow it to bend but prevent it from splitting. So as you can see here, we tried quite a few different methods and materials before landing on number 6 there in the bottom right corner. Which is a double layer of iron-on fabric interfacing. And it seemed to work for what we were doing. And so that's what we went with.
On the laser cutter, we tested out a couple different materials. The first material was 1/4-inch birch plywood. In the top left picture are the different speeds we tested. The purpose for the testing the speeds was to find the right speed that cut through the plywood in one pass and caused the least amount of charcoal on the sides. Because the plywood works so well, we wanted to use the plywood for our light until we got a second batch of the plywood and discovered that the laser cutter couldn't cut all the way through the plywood in one pass. Once it finally did cut through, the sides were extremely burnt, as you can see in the right picture. After some research, we found the reason the plywood burned was due to the type of glue used in the plywood. Because it was not easy to determine the types of glue in the plywoods we were going to buy, we decided to try out 1/4-inch MDF. Our concern with the MDF was the amount of formaldehyde in it. If the level of formaldehyde was too high, it would be toxic to use in the laser cutter. We looked around and found that MDF sold at Home Depot had a low enough amount of formaldehyde, making it safe to use in the laser cutter. After doing some different speed tests, we found that 4.8% speed met our requirements, as you can see in the bottom picture. We also used the laser cutter to cut out the veneer. This allowed for a more efficient and accurate way to get the correct size and waste as little material as we could. Once the veneer was cut out to the correct size, we were concerned not enough light would pass through the veneer. So we experimented by laser engraving the veneer, as you can see in the far right picture. When we laser engraved the veneer, we found that it made the veneer too fragile and caused it to crack. We then decided it wasn't going to work and found that more than enough light did shine through the veneer without laser engraving it.
This is an example of some research we did with different finishes on some scrap pieces of veneer we had. This test in particular was geared to provide us insights on the effects of finishes on different veneer. From this, we decided to go with an oil-based poly finish as it displayed the least amount of warp on the material. From the data we gathered during production, we found it took us approximately 7 hours to create our first unit. However, it only took us 4 hours to complete our second unit. This results in a learning curve of 78.6%.
We had to create a pilot run of 10 units. And one of the things that helped us sort of make it the same way every single time was the creation of process sheets and route sheets. And a process sheet is basically just a list of steps that have to go in that particular order for you to get, the pendant. And each one of these numbers, all the way 1 through 20, corresponds with a route sheet. And the route sheet is, I guess, an even more in-depth look at the process sheet. It gives you sort of how long it's going to take, what you're going to do, the machines used, the tools used.
This is one of the work instruction sheets we had to make. The one on the screen right now is for the laser cutter. Work instruction sheet is a step-by-step guide on how to make a specific part of the light. The sheet was very helpful because it allowed for anybody on our team to make any one of the parts.
So here's our critical path diagram. It is basically showing us the steps that we took to arrive at our final design and the amount of time that each step took us. The critical path itself are the steps that brought us to our final design in the most timely fashion. And so the numbers that you can see in the top left and top right indicate the early start and early finish dates, respectively, based on the steps coming before them. And the bottom left and bottom right are the late start and late finish dates for that step. Our process was basically coming up with a design, building that design, then testing it, finding the issues that came with it, We then redesigned and built a new prototype and continued that process. It took us a few attempts to find our final form, but what this diagram is showing is the time frame for that.
We had mentioned early on that the veneer was going to be incredibly problematic. So to find sort of the root cause of the problem, we created a fishbone diagram. And the fishbone diagram basically just illustrates all the potential things that could go wrong when using the veneer and why they're going wrong. So you have material, the measurement, which is really just the tolerances, and then we were thinking, maybe we should change the design altogether if the veneer actually can't create a perfect cylindrical shape, which is why we cut the veneer in half and now had two pieces. And then this one in the corner method, we had gone through a lot of different methods to actually apply the veneer to the pendant. We were thinking about glue, and then we were thinking about not using glue, and then we were thinking about some sort of, iron on or tape even. And we had eventually settled on wood glue in a press that you will be introduced to later.
So when we started processing these lamps, one of the first things we had to do was to process the veneer, since it took one of the longest out of all the steps. So in order to do that, what we did first was we ironed on both backings of the fabric interface in order to give it that reinforcement that I discussed earlier. And then we hit it with the oil-based poly and let them dry in the sun for about 4 hours before bringing them back inside to give it another coat, and then allowed it to dry again overnight before giving it just a quick rub over with some sandpaper just to get off any blemishes on the outer surface of it. So these are the MDF frames that we used as the skeleton of the lamp. They help it to hold its shape and also provide a mounting point for all the pieces of the lamp. Our frames here consisted of a long rectangular piece that we refer to as the bridge and 2 elliptical pieces that we refer to as the bases.
So here we are showing the internal electrical portion of our pendant light. And so this part was very important because the lighting needed to be compact and have the ability to hold the weight of the entire piece since we are hanging it from the ceiling. So we decided to use LED light strips for their powerful light output, their low heat emission, and easy application. A wire straining relief was also used to keep the force of gravity off the electrical wires and maintain the integrity of the wiring unit. The LED strips were applied to the inside edges of the MDF frame, and initially we were going to use some sort of light diffusion technique because the individual lights of the LED strip were going to be visible, but the stain of the veneer ended up doing a pretty good job at that. The wiring was then fed through a hole in the MDF frame and attached to the Canopy Electrical above. So here we can see the Canopy Electrical unit, which consisted of a 3D printed mount where the hardware attaches to. There is the power supply unit and wire connections. And this assembly is key to the pendant being able to be hung from the ceiling. Here we are showing the assembly of the canopy structure and the pendant being hung for the first time. As you can see, the light is being diffused very well by the veneer, and the pendant is hung with the strain relief holding the weight of the entire piece. And these are the different labeled parts of the electrical system and the tools that we used to wire it. We used heat shrinking to insulate the wires and also provide some abrasion resistance. And crimping the wires was another process that we used to keep the wires in place and resist corrosion over its lifetime of use.
So the first jig we made was the squaring jig, and this was assembled to align the 3 consecutive MDF frame pieces, also known as the bridge, and we glued those each to each other, and then we went ahead and brad nailed them together to ensure a secure fit. And we used a notch system along the outside of the jig to keep the pieces perfectly in place and square to each other. And then the second jig we made was the press jig prototype. This was a mock-up that we made out of medium density foam. This was cut out with the laser cutter and the bandsaw. And we made this to get an idea of what our dimensions would be on our final press jig. We realized quickly that the medium density foam wouldn't withstand metal fasteners, and the adhesive wasn't holding very well on it. But we did use a low density foam set of runners along all the pressure points, creating a pillow for the veneer to glue on all of the frame around the outside. So we went ahead and made a final out of plywood. And this final press jig, as you can see, we made out of plywood. We used a tab system on either side, and this was stapled together to reduce the error of aligning the frame onto the veneer. And we also used a low density foam set of runners along both the top and the bottom to ensure that the veneer wouldn't get scuffed up and would have a nice pressure fit to the frame. We left an overhang on the outside of the veneer so that we'd go back later and use a fine handwork, and once we take it out of the jig, to ensure that the quality control would be at its finest. And the constant pressure was delivered to the top of the jig, and this was a twist clamp.
So after the lamp came out of the press jig, the sharp edges had to be sanded down to prevent damage to the piece. And since we're making 10 identical pieces, it was important that the amount that we sanded off was the same on each lamp. So in order to do this, we created a jig that would butt up against a spindle belt sander for a reliable, accurate material removal. The biggest problem that we had with the sanding jig was how we were supposed to index it. So what we came up with was a stationary block on the left with a notch cut out of it for the wires to fit into. The block uses the cutouts from the base parts to prevent the lamp from twisting. And on the other side, we have a block with similar indexing system, but instead of being stationary, it slides back and forth to clamp the lamp into place while we're sanding. In order to hold the lamp tightly without crushing it, we had to add this piece of white felt to the sliding block to widen the tolerances a bit and give it that nice cushion so that, you know, you're right in between holding it tightly, crushing it, and holding it too loosely. These are some of the examples of the fine handwork that we had to do after the lamps came out of all the jigs. There was still quite a bit of fine tuning that had to be done. Just you know, comes with each lamp was very unique. So some things that stood out were on the left there. You can see we had to go along the edge with a razor blade to try to cut off any extra interfacing that had maybe gotten tore up in the sanding or had been left behind. Another thing, like Aiden was just talking about, is that after the lamp came out of the press jig, we had to cut off the excess on the top and the bottom, so the excess veneer, I'm sorry, on the top and the bottom, in order to, you know, be able to fit it into the sanding jig. And we had debated sanding it off, but we were afraid that if we took a sander to a piece that thin, that it would cause cracks and splits along the entire length of the lamp. And the final picture depicts us sanding off the edges of the bases, because after they come out of the laser cutter, they have that charcoal edge, and wood glue will not stick to charcoal. So we pretty quickly figured that out and just sanded off the edges to give it, you know, veneer against MDF rather than veneer against charcoal.
Here we see the accounting document that I maintained throughout the project. It includes a complete list of materials with corresponding part numbers and order quantities, as well as the cost of said quantities, the cost of individual unit price, and the cost to produce a lot of 10 units. At a sales price of $55 and a cost of materials of $49.71, this results in a profit of $5.29 per unit. This is a chart depicting the location, time, and percentage of time spent at various tasks and locations in the shop. If this project were to continue to a full-scale production, this chart would be a critical piece of information in attempting to cut manufacturing costs and streamline production. Both myself and the rest of my colleagues would like to thank you for taking the time to observe this presentation, and we will now be opening up for questions at this time.
A great job. What a great job. And I'll give a round of applause here. So there is some couple of questions in so there's, let's see, we're seeing awesome, it's an awesome product. So one question, how was the excess end material removed without splitting the veneer?
Yeah, so I kind of went over that pretty briefly on the fine handwork slide, but we pretty much used a razor blade and just really carefully went and just scored the veneer over and over and over again until it came off pretty seamlessly.
Great, thanks. So here's another question, and actually this is from one of our alumni. She says, this is Megan Shaw. She says, a great project. What are some of your greatest obstacles that were overcome while completing the project during COVID? The old COVID adaptations. Does anyone want to jump in there on that one?
Yeah, I mean, something that I was worried about is, one of the teammates going into quarantine, and then we would lose one of our teammates, or then maybe lose two of our teammates. And thankfully that didn't happen. But that was a fear of ours throughout the whole thing. And aside from that, I mean, there were some minor problems. If I remember in the beginning, we structured the class where it would be sort of one half attends via Zoom and then the other half attends in person. And sometimes the logistics of that and just sort of overcoming that was very, very frustrating. But as the class progressed, we sort of, we sort of learned to live with the new norm. Ordering materials, things were taking a little longer than what they typically would have. But yeah, that's
good.
The biggest thing is nobody wanted to quarantine.
Yeah, thanks, Liam. So we've got another question here from Mike Jablonski, who says, well, actually, Marilyn says, where can I buy one? I think they've all sold, maybe, but we can stay after. We'll figure this out. And then Mike Jablonski says, loves the topic. Nice change. Did you talk about some of the regulations that apply to lighting? I think you referenced some of that. Does someone want to answer that one?
Yes, on the electrical portion of the presentation, actually in the beginning of the presentation, I had mentioned that William Mullen wouldn't be joining us. He was our sort of go-to electrical guy. And he had done a lot of extensive research into, obviously what is okay to put in the light and what is not okay to put in the light, and, what can go in a house and what cannot go in a house. And that was his sort of forte, and I was kind of a hands-off, leader, I guess, in that aspect. I just said, you know, make it work, and he did the research and he made it work. That's kind of a hollow answer, but I mean,
I'm wondering if Isaac maybe could mention something. You talked about the strain relief piece here and meeting some of the UL requirements there.
Yeah, as Liam had said, Will was definitely working on the UL requirements a little more than I was, but the strain relief was definitely one of those requirements, and the way we were able to fit it into that 3/16 inch hole was one of the challenges that we faced, but we were able to figure it out, and it ended up working out pretty well.
Maybe I just want to add something. So yes, according to the suggestion from Dr. Hicks, I just shared this book with them where they got like tons of rules and regulation when they will use the electronics piece. So yeah, I think they followed accordingly.
Great. Well, thanks. So we'll have more Q&A after the next one. We're having some great comments here about that these would be flying off the shelves if they were in the marketplace. So this is great feedback. So thanks. So how about if we start the next one, and then we'll have Q&A for that, and then we'll open it up for bigger Q&A, and I'll try to get through some of these great questions, and we'll try to get through them. Okay, thanks.
My name is Mark. I was the manager of Chessboard Electronics, making our electronic headphone stand with our accountant, Ben Kranak, our quality control managers, Jack Herlihy and Chris Higgins, who isn't here with us today, our manufacturing engineer, Ben Musese, and our design engineer, David Ardolino. So this project was just us getting into a group to make kind of a mock company, which is our company, Chessboard Electronics, finding a need or a user group that we wanted to work with, find a need of theirs that needed to be solved, and do a whole bunch of everything that a company does, from user research to marketing, prototyping, testing, and up to selling and manufacturing the product in a small little run of 10.
I'm Ben Kranak, and I was the accountant for this project, and I also helped create this promotional video that we're going to share with you, displaying our final product that we've created. Once we had this idea of what we wanted to create and what functionality we wanted it to have, we took to the internet to do a preliminary user market research. We looked at what else was out there in terms of wireless charging headphone stands, and we set some goals for ourselves in terms of trying to be able to charge a certain number of electronic devices. Based on our research that we collected, people were set on potentially charging up to 3 devices, including their headphones, phones, computers. And we also wanted to do something that was going to save space on someone's desk, so that their phone, headphones, and whatever else was charging would be in a nice kitty corner spot. Many people said that their desks were cluttered, and we wanted to solve that for many people, as many people as we could. So we see here that we just kind of broke things up by what they could do and how much they cost. And as you can see, they're all pretty small. They all generally have up to 3 charging ports and the capability of holding a headphone stand or a pair of headphones. So with that being said, we designed a little market strategy of our own, comparing the price point that we see out there on the internet. We ended up setting our price at $70, which is a very competitive price compared to what else is out there. And in terms of getting our product out there, it was a group project, so we all have plenty of connections, and we were able to expose this idea to our peers first and foremost. And in terms of going further, we could easily create something beyond just the commercial we have and put it out there on the internet for more than just our peers to see in this presentation. And it is something that should catch many people's eye, as it has plenty of functionality to compete in a market of electronics.
Hi, my name is David Arlino. I am the head design engineer for Chessboard Electronics, and here's our prototyping. So when we first started this project, Mark had already designed and 3D printed the first model for personal use. We took his original design and tried to make it more complete. Our design would need a hollow base to hold the electrical components, and it would need an arm for the headphones to rest on. We tested many materials and forms to see which ones that would work. One of the material we used was a clear acrylic, otherwise known as plexiglass. We were able to cut it on the laser cutter, heat it up, and put it in a mold and bend it to shape. So the design iterations, as you can see, after testing out each prototype, we removed any features that seemed unnecessary and just trying to slim it down. And we wanted to adjust the size to make it more compact so it wouldn't get in the way of the customer. The final design features a wireless charging bed on the top of the base, 2 USB charging ports, and an RGB light with a color changing remote. The design is manufacturing friendly. The base will basically hold itself together even before being glued because of the finger joints. The bottom of the base is etched to match all of the electronical components, again, just for ease of assembly. And all charging slots are pre-cut in tolerance on the laser cutter to ensure a tight fit. Finally, the customer can choose the color of the base they prefer for added customizability.
So to keep ourselves organized and make this process as repeatable as we could, we had every part that we had organized with part numbers and names. So we had everything that we needed drawn out in SolidWorks first so that we can do all our test fits in there before we built anything. And then we were able to take those SolidWorks drawings and convert them into 2D drawings that we could put on the laser cutter. So everything could be cut and etched quickly and with good tolerance, right, one after the other.
I'm Jack Hurley. I was part of the quality control team. And so this is a breakdown of the electrical components we used. And as you can see here, to keep it streamlined, we use a USB hub with 4 ports so we could connect the wireless charger, the LED board, and the other 2 USB extensions for charging. And we use this because it kept it much simpler for assembly, so we didn't have to do any wire splicing or any soldering.
I'm Benjamin Msese, and I did manufacturing engineering part. For our jigs and fixtures, when we did our first acrylic, it was good, but until we tried the headphones, when it came out the way we didn't like it, the top view was not bent enough, so which made us redo it again. We had to resketch it, take it to bandsaw and cut it, and that was our final sketch.
This is a fishbone diagram outlining some of the challenges we face with the acrylic arm mold. We broke it down into 6 categories: procedure, environment, material, machine technology, measurements, and people. One of the first procedure challenges was just imprecise molding because it was all done by hand. The workspace or the environment that we had to create these in was also challenging because any dust that would accumulate on the acrylic would stick and leave it with a poor finish. And that also just kind of, that was a whole problem with the material itself because it was not scratch resistant. So mold defects were very easy to occur. And then with the oven and measurements, that was kind of the same problem. So any inaccurate oven temp would either result in it being too hot or too cool. So the acrylic could melt or it just wouldn't form because it was too rigid. And then as this was all done by hand, there would be some slight manufacturing error with each unit. So they could end up being slightly different.
So using tools like the Fishbone diagram to identify where our problems were coming from, we could come up with solutions. So the first problem we ran into was the arm holding the headphones was too flimsy. It would bend too much once you put the weight on it. So we tried a few different things, like giving the arm a little cup to add rigidity. And it worked a little bit, but not as much as we hoped. And it made the molding process a lot more difficult. So we scrapped that idea. Then we tried adding different contours to the arm, again, to try to add rigidity to it, and just didn't work out at all. So the solution we ended up with was just getting thicker acrylic. It was a little more expensive, but it was easier to mold with, and it held its shape a lot better. The next problem we had was the mold giving the arm a rough texture. When we just cut a piece of foam with a bandsaw, it would leave jagged edges, and that would translate into the acrylic and look really bad. So we tried adding a foam padding on the outside, or a felt padding on the outside of the foam. And that helped a little bit, but would result in some weird creasing because it just messed up the tolerances of the mold. So we ended up switching to a harder kind of foam and just spending a lot more time sanding it. So once we had one really good mold, we had a lot less problems with the molding process. And then the last problem we had was the plastic would kind of fold and crease during the molding. So we figured out if we bumped the temperature up a little bit and switched to a better oven, we started using my kitchen oven instead of the one we have in the shop because it was just a lot more accurate. And using our hands with heat gloves on to kind of press it into the mold before we clamped it down helped to prevent those wrinkles we were getting. So a lot of trial and error. Like I said towards the beginning, we wanted this to be a real production process that would be repeatable by somebody else. So we made work instructions where we would have a step-by-step with diagrams, instructions, so that anyone could pick this up with the materials they need and go and build their own, whether it be on their own, like a DIY thing, or in a factory. So with all this, you could see exactly what you need to do in what order, and anyone could make them. And there were a lot of steps that we put in there to make this a lot easier, like etching in the locations of the electronics, making those finger joints so that everything goes together without needing a jig and things like that. There were a lot of managerial tools we used to keep ourselves organized. The biggest one was the Gantt chart, which we would use to set goals for ourselves throughout the semester. So you can see all the way on the left, those are just the more broad general goals we knew we needed to get done. The blue lines are when we thought they would get done or hoped they would get done, and the green is when they actually happened. So you can see there's not a ton of overlap there, but we did the best we could, and it just kind of helped to have us get a feel of when things need to be done by. And as well as the whole semester long one, I would make a Gantt chart every week of exactly what we needed to do that week and what days we needed to do it on. Again, just to have those goals and times to keep us going and make sure we didn't forget anything.
This is our learning curve slide where we were keeping track of how long the average time it would cost us to make one unit. And we would compare that throughout the number of units we made, first, second, third, fourth, and fifth units, and how long each one took. As you can see, the first one on average took 11.5 hours, which is a significant length of time, versus just over 8 hours for the second unit. That shaves off about 15% of the time that it took us to make the first unit, meaning it only took us about 85% of the length to make the second unit as it did the first unit, which as we continue to make more units, we would expect to see a similar number potentially by the third unit. We should be looking at the same 85%, closer to maybe 6 or 5 hours of production in terms of making one unit.
So this is our quality inspection. We did this after all our assemblies were done for each unit, and basically consisted of making sure each had all the parts and that it was free of things like chips, burns, and scratches, and that correct materials were used and it all lined up exactly as we wanted. So the acrylic arm would fit flush into the base. So if all the electronic components were working properly, the LEDs would shine through and give it the look that we desired.
While making the headphone stand, we ran into a few problems. I think our biggest problem was time. We definitely did not do a great job of calculating how long finishes would take to dry. And we actually almost pretty much forgot to account for how long the glue would take to dry. So that accounted for us like pretty much working until the very last minute on this project. Another problem that we faced was the MDF. While it was really easy to cut and it was good for tolerancing, it was not very durable. So even with the finish on it, if it got any chips on the edge, it was prone to peeling.
And another challenge that was, as the accountant, very big was the cost management, which this course gave us a very in-depth look at how much it costs to produce 10 models in a production run. We experienced a number of different problems in terms of sourcing our materials and finding the cheapest and best material and electronic devices for our final production. Going off of that, the accounting analysis here done up by me shows just a list of the materials we used, from the purchased electronic components to the purchased cut materials such as the MDF and acrylic. As you can see, looking at the top right off of the bat, the electronic components accounted for more than 75% of the total $57.22 that each final product cost. And here's a better representation of that breakdown, just so you can really see how much items such as the USB hub and the wireless phone charger cost in comparison to things such as the acrylic arm and the base, top, and bottoms. The MDF and acrylic were priced at a point that was pennies to cut out our pieces, whereas we tried cutting down the cost on the electronics with little success. We did actually cut our USB extension price in half, as we used to be paying $10 for a pack of 4. We were able to get that down to 5, which is a 50% cut, and helped us get to the price point of $70 that we reached, giving us approximately a 15% profit margin on each individual product.
So we had a lot of educational experiences throughout this process, mistakes we made, things we came across. Like David had said, time management was our #1 by far. Just thinking about the critical path of how one thing is going to take a lot longer than another thing, and we should have started those things earlier, as well as accounting for drying times for finishes and glues. But besides that, there was still a lot to learn. We all got a lot of practice with the laser cutter, etching and cutting. Sharing the shop with another team was a big thing for us to figure out. Both of our teams were working at the same time with the laser cutter really extensively. We had to figure that out. With COVID, we can only have so many people in the shop at once. So finding a time that not only our whole team could be there together, with our school and work schedules, but also that the other team wasn't, was an interesting challenge to work around. We figured out how to heat and mold acrylic the most efficiently we could with the tools we had. We all dealt with new finishes on new materials. None of us had really worked with MDF before, so that was a learning experience. We definitely learned the importance of material choice. We couldn't go with the exact materials we wanted to because of constraints besides aesthetics. Like, we wanted to use wood at first, but we just couldn't work with it. The plywood that we were using just wouldn't cut properly on the laser cutter. It would burn too much and mess up the tolerances. So we had to settle for MDF, even though it wasn't the prettiest thing. It was just the most practical choice we had. We had some supplier and shipping problems, as I'm sure everyone has had experience with. Things ship late, they get delayed. The supplier switches the material on you without telling you, and suddenly you have a bunch of useless material you just paid for that you can't use. All that kind of fun stuff. The costing, like Ben already talked about, the manufacturing process of, streamlining everything to make it as efficient as we could, and production timing. So moving forward, if Chessboard Electronics were to live on, the first thing we'd like to do is add custom laser engravings on the MDF acrylic, which we did plan to do and just didn't have time for. So as we are cutting out those pieces, we can add on custom words and logos and things like that for it to etch in as it's already cutting the pieces, which we could charge more for if we wanted to increase our profit margin a bit without much extra work. Besides that, we'd like to see if we could offer different color finishes besides the clear and the black. Definitely resource our electronics. As Ben was saying, that was a huge cost from us because we were buying them as consumers off Amazon. So if we could wholesale buy those electronics, it'd be a lot cheaper. Resizing the MDF pieces to account for the sanding would be good so that things actually stay square like they're supposed to. And definitely exploring alternative base materials because, like I said, even though the MDF worked, it isn't perfect. So thank you everyone for listening. Thank you to Zach Stephenson for our help in the assembly process. Definitely couldn't have finished it without him. And if anyone has any questions, we're open to them now. Thank you.
So wonderful job. Thanks so much. I think it's okay if we go over our 1 hour here. I'm hoping our participants are still there, and we've got some great questions here too. One of the things I think for this team, what would be your biggest takeaway? I know you did some of the things you would do differently, which is great. What would be your next steps? But how about as a team, what's some of your biggest takeaways from the project? Anyone want to jump in there? What worked well for you, and what can you take forward into your career?
Yeah, I can try to answer that. There's certainly a lot both ways. Things we wish we'd done differently and things that we're glad we did the way we did. I think for at least me personally, communication was a big thing. I wasn't planning on being the manager. I didn't want to be the manager. And I wasn't great in the role, but I feel like I did improve throughout it. And I definitely took away a lot of good lessons from, listening to the team and trying to change things, because the design changed very significantly throughout the process. And, some of those changes were easier than others, but so, that was a big lesson for me and all of us.
Great. So here's another question. And again, lots of compliments. This is great. And this, what was your biggest challenge? Well, I think you did talk about it, but any other thoughts on the biggest challenge in completing the project?
Yeah, that was definitely just the time. Again, partially because of how often we changed our design, we really were down to like 2 weeks with our actual production and assembly process after doing everything else. All the testing and material problems we had, the design changes and things like that. I think David said in the presentation, we never really accounted for things like glue drying times when we were planning our little production sessions. So time was always our biggest issue. You know, time for shipping, time for drying, time for working, time for, you know, getting everybody into the shop at the same time. All that.
Great. Okay, so I see that Bruce Norland has his hand raised, and I'm going to give it a shot here to allow him to talk, and let's just see if we can hear him.
My question is, did you consider using ultraviolet adhesives to shorten your gluing time?
No, we didn't. That is a good question. We used wood glue for basically everything. The finger joints of the MDF made for a lot of surface area to glue, so we didn't need anything particularly strong. So we just went with the fastest drying wood glue we had. Had we planned ahead and done a little more research, that absolutely would have been a better option, I'm sure. But you know, we would have had to go and get the special glue and some UV lights for curing it. But that is a really good point. That would have been better.
Thanks. Great. So there's another question from the Q&A that is, in a sense, actually for both of you, both teams. There's a question about what do you think the materials cost would be if you had a much larger production run? I know that you were thinking about, I know that the electronics group mentioned some of their cost of some of the major electronic components, but thinking about if you were, say, got an order for a lot of these and wanted to ramp up your production, any thoughts on what the material costs might be reduced to? I don't know if you were able to really work on that or not, but any thoughts? And then for both groups.
Yeah, as far as material cost goes, I'm sure we could get everything a lot lower instead of buying individual items from Amazon and Home Depot and things like that. However, we did kind of cheat on our costs in the fact that we didn't really include labor. And this was a pretty labor intensive process. And if this was a big production run, we couldn't have a bunch of college intern slaves like we had here. So we would need to actually pay a assembly facility of some kind to make them, which I'm sure would wipe out any cost savings of the higher production or the higher quantities we bought materials in. So materials would go down, but I think the overall price would have to go up.
Yeah, good point. Great point to recognize that, you know, yours was a labor of love. And so, but recognizing you did track the hours, so you could do those calculations and then see what that would track. Yeah, great. Okay, so I'm wondering from the Pendant group, what do you think? Any thoughts about what your costs might be reduced to in terms of material costs if you went for a large production run?
Yeah, I can speak on that if you'd like.
Great.
Much like the headphone stand group, our accounting doesn't necessarily account for the cost of things like overhead, labor, and factors like that. We did track hours though, and if we were going forward, especially on the labor points, that would drive the cost up a bit. We had originally set like our goal was to sell this at $70 or less. When we went into this design process, that's what we had in mind. And as you can see from ours, we came in well under budget. However, again, not accounting for that labor. With labor, especially now that all the research and development and design is already completed, we just off the hip calculations in my head, I imagine that we might actually be able to still meet that $70 like mark that we were looking to hit.
Great, thanks. Thanks. So I think the Charger group did talk about the things, the processes that they would look to improve and how they would do it as a team. This was a question from your audience, but I think I'm wondering if the Pendant team can answer that. Which of those processes would you want to improve, and how would you approach that as a team?
Something that I think definitely would need to be improved is the actual removing the veneer on the top and the bottom part of the pendant. We didn't have any sort of jig or any sort of special tool to actually do that. And in the presentation, we just called it fine hand work. And doing that, it's very, every cut you make, you're sort of in your head, you're thinking, oh man, this could snap in any second, and you're cutting it like 10 times, you need like a new blade for every lamp. And maybe we didn't think we needed a jig for that, or we ran out of time, but that is something that we definitely would have made a jig for.
Great.
And even the jigs that actually press the veneer onto the MDF frame, we could rework those as well, because the actual aligning them, the alignment of the top and bottom pieces weren't always perfect.
Great, thanks. So I think we just have time for maybe one more thing, and Mark, you gave a great answer to what was your team's biggest takeaway. But I'd also like to put that out to the other team and anyone else's big, what's the biggest takeaway in terms of, what's a learning that you've can take forward and help you in your career?
Definitely time management.
Time management, we heard it again, yeah. Yeah.
Yeah, time management's a big one.
Sure.
And
that's
understanding
great.
that, and how much time is we need to dedicate to actual design and research. It's not just, oh, you're going to design something and, building it is the hard part, I think. Or at least I don't mean to speak for the rest of my group, but I found the actual building aspect is the hardest part, and how it's going to be built that was a learning curve for me, at least.
Yeah, I'd have to agree with Liam. One of the things on that kind of topic that I am taking away from this project was in the design process, like it's all good to design for design's sake, but when you're designing for a production, especially for a larger production, it's nice to keep in the back of your head that this is going to be a product that is created many times, and kind of the ease of assembly is definitely a consideration to keep in mind when doing your design.
Great, thanks. Well, we haven't been able to answer all the questions from our Q&A, but thanks so much for everyone's for joining us. We have, and congratulations to all of you students. We're getting some great comments here, really nice work from both teams, blown away again. Just, great team building. I'm just reading through some of these. Design looks great, stylish, unique, just some great great comments. So you all did a fantastic job with this project. And I just want to say thank you for putting together this presentation and sharing it with our community too. So these are folks that are on the folks that I'm seeing here in the participant list are SME professional folks that live and work in this area and in manufacturing. And then we've also have a number of alumni as well. So, and I'm getting another text here. It says, very good presentation tonight. So this is great. So anyway, thanks so much. If there's any other Q&A, we can hang on here if there's some more, but I understand we're a little over our time here. And thanks for everyone for joining us. And we've got more. Great job. Great job. So.
Yeah, good evening. Can you hear me, Dr. Hicks?
Oh, yes, there we go.
Great. The professors that helped you and the students, this is exactly what we're teaching as programs to go into the workplace. When you get out here, you're going to need to know these type of things on how to put together a project, and you'll be put together with a team, and you'll be new on the team. And what you just put forth tonight is very strong for what you're going to need when you hit the workplace. So thank you. A great job. I really appreciate it.
Great. And now I see another raised hand here. It's Curtis Butler. I think you can go ahead.
Hey, can you hear me?
Yes, sir.
Just a few comments for you guys. Excellent presentation from the little bit that I was able to glimpse while driving. Just a few notes. The electronics group, if you bought those units from a Chinese vendor, are they still UL listed? I was not sure, and I didn't see any pictures indicating that. And if you are opening up any of those units, you could potentially be jeopardizing the UL listing. And then I believe I heard one gentleman note that he was forced into the managerial role. Congratulations. It sucks from here on out. But it won't help you from a communication standpoint. If there's one benefit that you can get from the COVID pandemic isolating us all, is building your communication skills is going to be very crucial for your success in the business.
Great. Thanks, Curtis. I think does someone want to address the UL piece? Because we did look at that in great detail.
Yes. So we did make sure that everything we had in there was UL approved. We even put a little thermometer inside and turned everything on for 8 hours to make sure it didn't get too hot. And we did not open any components. That was one of the reasons we used that little hub of USBs, so we could avoid any soldering or anything and just plug everything in. So we did check up on all of that.
Excellent.
Yeah.
Yeah, so they actually did the type of UL testing. They did burn tests, burn it in which is the heat tests, have it on for a period of time and test the temperatures. Yep, absolutely. So great. Let's see, is there other, let's see.
Oh, am I still on?
You are still on.
Oh, perfect.
Okay. All right. Is there any other? Now, if let's see. So
yeah,
anyone who's go ahead.
I think I can just read like a couple of lines from an email I got from John Smith Medical. So he's very happy, and he's saying, I'm incredibly impressed by this class and somewhat embarrassed by my presentation in comparison from back in the day. Yeah, so some good thing, great.
Well, I think I think we've had a great presentation here and some really great comments from our participants. We had, I think it was over 40 at one point on the participant number, which is fantastic. So someone said something?
No, I said at some point it was 42, yes.
42, great, okay. Great, okay, well, I'm just gonna say thanks all for joining us, and thank you to the students for a great job, and really thumbs up, both 2 thumbs up, great job.